Hello everyone, my name is Albert and my work is entitled Mass Spec-based untargeted metabolomics approaches to explore the anti-inflammatory bioactive markers of Brazilian Ocotea species. So, the Ocotea genus is considered one of the main potential sources of bioactive agents in the Lauraceae family, and several species are recognized by their traditional use in the popular medicine in South America. Moreover, the genus is insufficiently known in the literature, and regarding the botanical features, the genus is considered as a complex genus. For the chemical composition, we find mainly alkaloids from the benzyl isoquinoline and aporphin classes, besides other classes of compounds. Metabolomics workflow. After sample preparation, the extracts were submitted to the bioactive assays, which included the prostaglandin E2 plasmatic determination using MSMS analysis, and this is a pro-inflammatory mediator. After the extracts were submitted to high-resolution mass spectrometry to generate the raw MS data. After the three-dimensional data, including retention time, values, MZ ratio, and peak area, were processed using unified software. After, they followed for data treatment that includes steps of baseline correction, peak detection, the convolution, the isotope, alignment, and etc., and export via CSV format. After imported through meta-analysis, software for the statistical analysis. Initially, so the results of the anti-inflammatory assay, 32 out of 60 species were statistically different from negative controls, and 12 out of these 32 were statistically similar to the positive controls, which were dexamethasone and indomethacin, as we can see in the chart. The values of P values were threshold at 0.05. For the unsupervised analysis, we chose the PCA, the principal component analysis, that after quantile normalized was with 5 components acquired R square higher than 0.5 for both ionization modes, which was well fitted for metabolomic studies. We also could observe in the 3D scatter plot that the analytical replicates in red and blue clustered together, and specifically the KC control in red cluster in the center of the plot, indicating that the data treatment was accurate. For the supervised analysis, we applied the partially squared discriminant analysis, which acquired very good values of goodness of fit and R square higher than 0.9 for both ionization modes, and good predictability values of chi-square higher than 0.5 for both ionization mode as well. And we performed 100 permutation tests to guarantee the absence of overfitting. Additionally, we perform univariate analysis. As in metabolomics studies, we have to handle with outlier samples, and in fact, we excluded 2 samples from the data set for statistical analysis. So volcano plot was applied to ensure no misleading potential compounds, and the threshold was established for p-value of 0.05 and fold chain higher than 2.5. And thus we use the p-values combined with the hierarchical clustering analysis to generate heat map for visualizations of the bioactive makers among the different active and inactive samples. And finally, the complete table of the putative annotation of the bioactive makers, and we could see majority aporphin alkaloids that were accessed via level 2 according to the metabolomics standards initiative, as we have used the fragmentation pattern and the proportion of the MZ ratio to propose the mechanism of formation of the main product ions observed in the spectra. So, as a final considerations, this work is the first chemical and pharmacological report of several endemic Ocotea species of Brazil, which supported the potential anti-inflammatory activity of the genus. And the present metabolomics research is also filling a gap in the literature and thus is corroborating for future Ocotea phylogenetic and phytochemical prospections. Thank you, all the funding and all of you.